In summary, we can successfully train a neural network with a more biologically plausible learning rule than the backpropagation rule. To show how to train in a biologically plausible manner, in this video, let me briefly introduce feedback alignment rule as a variant of the backpropagation rule. Let me briefly refresh your memory on the backpropagation rule in the simplest one-dimensional case, where the input 1 is multiplied by 1.1 to get the middle layer activation 1.1, which is further multiplied by 1 to get the output 1.1. The difference between this predicted value and the target value is the error. The issue here is how to tune W1 to correct the network's output. In this simplest case, we can just add error to W1, then W1 should be updated to 1. Now the updated output becomes 1 and there is no error. That means we successfully learned this first example. The situation becomes more complex when W2 is negative because multiplying by W2 reverses the sign. Whether to increase W1 or not matters. In this second example, we need to add negated error to W1 actually. In another word, we need to multiply error by W2 before we add. Then W1 should be updated to 1. Now the updated output becomes -1 and there is no error. That means we successfully learned this second example. However, to update W1, we needed the information on W2, which is far away. This is known as the weight transport problem. The brain should update a synaptic weight only using the locally available information, but it is not the case with the backpropagation rule, unfortunately. Therefore, the feedback alignment rule was proposed as a biologically plausible alternative. There, as highlighted yellow, a fixed random number is multiplied to error before we add to W1. We demonstrated that this rule worked after both W1 and W2 are updated many times. Finally, we even found that using 1 instead of a random number works for simple image classifications. Thus, the learning rule can be very simplified actually.